Well, hello. It's time for another little talk about GigaDevice, particularly about RISC-V or RISC-V technology. I've recently held a little inquiry on my Instagram account and also with my friends in the field engineering applications division of GigaDevice, and I've collected like a dozen of interesting, strange, whatever talking points about RISC-V technology. Some of them are commercial, some of them are more technical. So right now you see a slide which basically shows you what we are covering and where you can jump to just get to the question which interests you. Either way, the format's gonna be quite simple. First you've got me blabbering about something, and then we'll be answering the question tour à tour. If RISC-V or RISC-V, as you say, is open source, why do I have to pay for the chips? This is not a joke question, by the way. We get this question quite often. Well, to answer the question what the whole open hardware is about, we need to look at the traditional process. We've got ARM here. ARM, they make basically a soft core. It's like an architecture description. It describes how the controller has to work and this and that. And in the next step, a vendor like GigaDevice licenses the soft core, and then he makes the actual system on chip or microcontroller. They take the soft core and they add the peripherals, which quite incidentally also explains why every system on a chip has a slightly different set of peripherals once sold. And either way, now here we have the system on chip. This one is then produced and is sold. And the RISC-V technology only eliminates this part of the game. It only takes out ARM. GigaDevice still needs to make money. The chip production company still needs to make money. So realistically, in theory, a RISC-V controller has to be cheaper than an ARM chip. But realistically, there are two reasons why this is not always the case. Or actually, there are three reasons. First of all, ARM is everywhere. So this means the controllers get produced in very significant large numbers, and thus the licensing fee is amortized. Secondarily, ARM is painfully, fearfully aware of the problems which they have with RISC-V, and so they are always willing to cut a deal. And finally, a lot of companies already have ARM work, and so they can reuse what they already have on new chips, and this also reduces the total cost of ownership. So in practice, I predict RISC-V and ARM chips to be more or less on par initially, with a benefit for RISC-V only coming out as volumes increase. Well, I know this question was a bit strange, but I really got it from field application engineers who had to answer it quite often. But down there, there's a box for comments. Why don't you ask a question down there so that I can make another video answering your question? Thanks in advance, and by the way, it also helps the channel grow. Well, another question. What is GigaDevice? Simple question, short answer. GigaDevice is the stock we all should have bought a few months or years ago. It would have made us really, really rich, as you can see in the diagram here. This, however, is only part of the rent. As you see here, there's a product selection guide, which I can always send you if you want me to. And if we look inside here, we find out more about GigaDevice. And the particularly important thing is this here. As you see, they don't only make microcontrollers, but they actually come from the flash memory space, and now they also do sensors and microcontrollers. And just in case anybody of you wonders, yes, the company is real, and they even have European offices, for example in London. So this is definitely a company where you don't need to be concerned about them disappearing into the night one day. And if we are already at it, the second question: why or how does this affect me in terms of the whole ARM NVIDIA ARM debacle? And how does going for GigaDevice technology make my life and my customers' life safer and easier? To understand this problem, we also need to take a step back and look at the big picture. Here on top, we've got ARM NVIDIA, which is now a US-owned company. They used to be British or Japanese before. And here at the bottom, we've got our client who is sanctioned. And now the question is how all of this bubbles through. And the answer for this is pretty simple. American trade sanctions usually bubble up the food chain. So here we've got the distro, and here we've got the semiconductor maker. And the sanction now can bubble up. So the distributor risks being sanctioned, the semiconductor maker risks being sanctioned, or in the end, even ARM NVIDIA itself risks being sanctioned. So even if the distributor is, for example, in Poland, and the distributor tells the American government to go and take care of their stiffy, it doesn't mean anything, because the semiconductor maker or his bank or anybody in this food chain can be hit, and if any one of them gets hit, obviously the whole chain is broken down. And the reason why GigaDevice breaks through this process with RISC-V is simple. We've got now GigaDevice on top. GigaDevice is a Chinese-owned company, so they practically are invulnerable to American sanctions, or almost invulnerable. GigaDevice produces locally, so the semiconductor maker is also safe. Then they finally also have their own distributors, which are Asian distributors. So the distributor also is safe. So in the end, practically, the whole sanction risk now lies purely either with shipments from you to the client, payments from the client to you, or customs. But as you see here, all of this vulnerable area, which we had before with the ARM, it completely disappears. So by going GigaDevice and using a RISC-V core, you can significantly increase your odds of not becoming a sanctions target. Well, I love to do it. You love to see it. I look like a fucking ghost. I know. Down there, there's a button. Like and subscribe. Thank you. And yeah, while I do know that a dedicated government probably can find a way to sanction you, and if they sanction your wife's underwear shop, realistically you must think of this. There's the 80-20 rule. We've got 20% of the people and we've got 80% of the BS. And so 80% of the BS will be loaded onto 20% of the people. And if you are a small operator and you are also difficult to hit, it is very likely that the US government will just say, screw him, because here there's a lot of meat, let's just go after those guys instead. Another question which I've been asked a lot is, what's the difference between a GigaDevice RISC and a RISC like particularly I was asked about Atmel RISC, but also between RISC-V cores from other vendors. And to answer that, we also need the whiteboard. To understand what RISC or reduced instruction set means, we have to look at this. We see here the number of instructions on the die and here the complexity. And traditionally, semiconductor vendors always try to go up, 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 up. And then many years ago, the idea was we put the limit here, we reduce the instruction set, we make a relatively simple die, and then we run it very fast, and we use compilers to create the more complex instructions by using multiple simple ones. This originally was the idea. Today, RISC essentially is a marketing name. It means nothing. So everybody can call his microcontroller RISC, and almost everybody outside of the x86 world also does. Now, when it comes to RISC-V, the RISC-V is an instruction set. So it essentially describes assembler language and how a controller has to behave. And in addition to that, there are also extensions, which can, but don't have to be implemented. And so even just in the official specification, the vendor already has the ability to create different types of cores. The one vendor implements the one extension, the other vendor doesn't. But the point where the YAC40 really takes off is the memory map and the peripherals, like I2C, etc. The RISC-V specification makes no mention whatsoever of these two areas. And so every vendor essentially is completely free to do whatever he wants. And so the consequence is that any program which does something of significant use, even if it's two different RISC-V MCUs, it's very unlikely that you're going to be able to move it because the memory map and the peripheral access code would have to be changed. In the case of GigaDevice, this, however, plays to our advantage because you see here the GD32 and the GD32VF, and there is a lot of communality between the two parts. So if you know how to program the GD32, you'll find a lot of old friends on the GD32VF. The next question is, okay, I've bought one of these boards. Now how do I program it? You see here, the typical beautiful white things. How do you program them? Well, the answer for this is, it depends. Essentially, there is a paid option, which I'm showing you right now. We had a video on it already. It's YAR. And in addition to YAR, there is also an unpaid option, which actually also is pretty nice. Well, what you see here is Nucleo Studio IDE. I'm starting it up, selecting a workspace, and we see it's starting up as a more or less normal Eclipse CDT based work environment. And then after the successful start, you see here, it's really a completely stink-normal system. You see here, for example, I have a small project which I have left over. Here you can then select any connected targets. And you see here, for example, the int main. You see here it's a Blink program and it uses these macros. You see GPIO init with some parameters. It's basically a classic Eclipse-based development environment, just as you would expect it from other vendors. Next question. Where do I get these things, the development boards, and where do I buy the chips? Do I have to go to Taobao or not? Well, the answer to this is a clear and resounding no. There are both established Chinese distributors and there is also TME of Poland, which are selling some or most of the products. I'm gonna go and take you for a little tour of what's available where. And before that, of course, I also have to tell you, always send me an email and I put you in touch with a field applications engineer, and normally they also have their own suppliers. So in short, it might be a bit more difficult to get, but not significant.
Well, as you see here, first of all, we've got TME. They, of course, are focused on Europe, but I really can only tell you the best about it. And you see, they have both the parts and also some of the development kits, as you see here, for example, for $33. And they also have the big one for $81. And as you see, they've got most of the chips, but they are not always in stock because there's quite a bit of interest. Next up is LCSC. You see, they only at the moment have the development boards, but as you see here, sometimes for a significantly better price. And then finally, there is Utsource. Currently, they don't seem to have anything, but my practical experience with them is that if you send them an inquiry and you are a somewhat decent customer, they will usually find the stuff for you.
And with that, we've made it to the end of the clip. Congratulations! I hope that this has been inspiring you, at least to some level, to take a look at what RISC-V is all about and to evaluate about using it in your own products. With that, once again, thank you for watching. Don't forget to like and subscribe, and see you around soon. Thank you!